Now I'm going to solve the question 2, but I'm starting from the second part because the first part is a diagram and you can easily see the relationships between r and theta and relating them with x and y. But if it will be needed, I will send you a separate diagram for the part A. Now I am working on the part B, in which we are asked to find partial theta over partial x, partial theta with respect to y, the derivative of r with respect to x, and the derivative of r with respect to y, where r and theta are the polar coordinates and x, y are the Cartesian coordinates. So before finding these derivatives, we start by building relationships, or let's recall the main equations. So because x equal to r cos theta, y is equal to r sin theta, if we square both sides and add them, this can be easily seen that x square plus y square is equal to r square. So this gave us an equation for r square, by using which equation we can calculate the derivative of r, or even we can take square root and r will be square root of x square plus y square. Similarly, if I divide y by x and r will be cancelled with r, so I will get tan theta is equal to y over x. This implies that theta is equal to tan inverse of y over x. Now I am going to use this expression and then we calculate the required derivative. So let's start with the derivative of this partial theta over partial x by starting with from theta. So theta is equal to tangent inverse of y over x. So let's apply derivative with respect to theta's partial theta over partial x, which is equal to partial by partial x on tangent inverse of y over x. And we know the following chain rule: the derivative, if we are looking for the derivative with respect to x of tangent inverse of u, that is basically equal to 1 over 1 plus u square multiplied with the derivative of u with respect to x. In other words, we have to multiply with the derivative of the inner function, and here the inner function, or we can say on the place of u, it's y over x. So let's take the derivative, keeping in mind that on the place of u we have this y over x. So the derivative of this tangent inverse of y over x will be equal to 1 over 1 plus u square, but on the place of u we have this y over x and we have to take its square. Then we multiply with the derivative of u with respect to x by using this chain rule. So this will be the derivative of the u, and on the place of u we have this y over x. Now let's simplify everything. So this will be 1 over 1 plus y square over x square into, now when I will be taking the derivative of this expression, because y is a constant with respect to x and only 1 over x is being differentiated, and the derivative of 1 over x will be negative 1 over x square, so it simply becomes negative y over x square. In this case, y is a constant with respect to x. We are treating y and x as independent variable, and so y is not being treated as a function of x in this case. Now let's simplify this expression. If I take the LCM in the denominator, then x square will move in the numerator, so it will simply become x square divided by x square plus y square, and here we have negative y over x square, so this x square is cancelled with x square. Sunny, because I'm using the calculation directly, if it will be needed you can ask me later that if there will be any confusion. So eventually this is negative y over x square plus y square, but we can notice that this x square plus y square is basically equal to r square. This is over here. So keeping that thing in mind, ultimately we get partial theta with respect to x. This is negative y over r square. So this is the derivative of theta with respect to x. Now we find the derivative of theta with respect to y. So theta is basically equal to tangent inverse of y over x. Now we are going to take its derivative with respect to y. So partial theta over partial y, which will be equal to partial y. Tangent inverse of y over x. So again I'm going to use the same chain rule, but this time with respect to y. So the derivative of tangent inverse of u, we know that is equal to 1 over 1 plus u square, and on the place of u we have y over x square, and then we have to multiply with the derivative of the u, but this time with respect to y, because it is being differentiated with respect to y. So on the place of u we have y over x. So this will become 1 over 1 plus y square over x square, and keeping in mind that this time y is the main variable which is to be differentiated and x is a constant, so that constant x will remain as it is when I will be taking derivative with respect to y, and the derivative of y with respect to y, because y is in the numerator, that will be just 1. So this is equal to x square divided by x square plus y square into 1 over x. So this x cancels with 1x. So it means that partial theta over partial y. So we are left with x in the numerator, and because this x square plus y square in the denominator is equal to r square. So this is the derivative of theta with respect to y is equal to x over r square. So now we start the derivative of theta, so the derivatives of r with respect to x and y. So r, basically we have x square plus y square square root. For simplicity, before calculating its derivative, I can rewrite this one as a x square plus y square to power half. Okay, now let's apply the derivative on r with respect to x first. The derivative of r with respect to x will be equal to derivative applied with respect to x applied on this x square plus y square to exponent 1 by 2. So again we are going to apply the power rule, but it is nested with the chain rule. So firstly I will be applying the power rule on this whole expression, then I have to multiply with the derivative of the inner function. So this is like the following thing, that if I am applying the derivative on some function of u, or I say u to power n, so this will be equal to n times u to power n, this is not x, n times u to power n minus 1, and then I have to multiply with the derivative of u with respect to x. So this is what we are going to do. So first of all, n will come the start, which is 1 by 2 and x square plus y square to power 1 by 2 minus 1, it will become negative half. Then we multiply with the derivative of the inner function with respect to x, which is x square plus y square. So this will become 1 over 2, and that x square plus y square to power half becomes positive in the denominator because it was negative in the numerator. Okay, now let's find the derivative of this expression. The derivative of x square with respect to x will be 2x, and because y is independent with respect to x, so that will be 0. So finally we can notice this 2 will be cancelled with the 2, so we are left with x in the numerator, and in the denominator this is x square plus y square. So this will be x, and x square plus y square square root is basically r, not r square but r. This is the derivative of r with respect to x. Now we calculated the derivative of r with respect to y. R is equal to the same x square plus y square square root. So this time I'm going to write the answer directly when I differentiate this r with respect to y. So finally it will be just y over r. This is the answer for that. And this was the answer for the derivative of r with respect to x, and this is the derivative of r with respect to y. It will be y over r. Now we solve the part C of the question 2. Let's read the statement. uh, as we already know, it was given in the beginning that f is equal to g. It's over here. So we are looking for the expressions of f of x, fy, f double x and f double y, and they should be in terms of r and theta, and of course in terms of g or the partial derivatives of g. Okay, let's solve them. So we are given that f of x y is equal to g of r comma theta, and we are looking for fx, fy, fxx, fyy. So let's find them. So I start finding fx, which means the partial derivative of x with respect to the partial derivative of f with respect to x. That's what we are looking for. Okay, so I start by writing the given expression for f of xy. So we are given with f of xy is equal to g of r comma theta. So let me apply the derivative with respect to x on both sides. So it will be f of x comma y is equal to derivative with respect to x on g of r comma theta. So on the left, for simplicity, we can just write fx. It's understood that f is depending upon x and y, so I'm just applying the derivative with respect to x. That is just an alternate notation for this one. On the right hand side, it is clear that g is depending upon r and theta, and of course r and theta are in turn depending upon x and y as well. So this time we are finding the derivative of g with respect to x, but in the very first side we can't see x over here, so here we apply the chain rule. So it will be the derivative of g with respect to r. So I firstly apply the derivative with respect to r on g of r comma theta into derivative of r with respect to x. This is a chain rule. If you can notice that this partial r is cancelled, ultimately I'm left with partial from here and partial x from here, which was given in the beginning. So but still we are not done, because this g is also depending upon theta, and theta is in turn depending upon x as well. So I will write that the partial derivative with respect to theta applied on g, and in turn the derivative of theta with respect to x. So ultimately you can notice that on the left derivative was with respect to x, and on the right I'm differentiating each parameter with respect to x only, not with respect to y. So you can notice from here basically partial theta cancel with partial theta, although we don't have to cancel. Ultimately we have partial over partial x. So this is the chain rule in this situation. Okay, so this partial over partial r g r theta will be written as just gr, and here we have partial r over partial x, which we have already calculated in the second part of the question. So partial r over partial x was x over r, plus this is the derivative of g with respect to theta, which is rewritten as g theta, and then we have partial theta over partial x. So let's look at partial theta over partial x. The value of partial theta over partial x, we have already calculated that, and that is negative y over r square. The derivative of theta with respect to x is negative y over r square. So let's simplify them. So it is x over r gr negative y over r square g theta, and this is the expression for fx. And I guess that you will have a little problem in understanding this chain rule. So after watching this video lesson, you can ask me and I will explain this thing. Now let's go to the partial derivative of f with respect to y. So again we start with the given thing. We are given with f of x y is equal to g of r comma theta. So I apply derivative with respect to y on both sides, and derivative with respect to y on the right side as well. The left side can be written as fy, that's just for convenience. On the right hand side we can notice that g is depending upon r and theta, although r and theta are depending on y as well, but they are not in the first side, so we apply the chain rule. So it will be the derivative of g with respect to r first, and then the derivative of r with respect to y. The same chain rule, but this time instead of writing g r theta, I'm simply writing g, and then the derivative of g with respect to theta, and also theta is depending upon y, so derivative of theta with respect to y. And you can notice that these partial derivatives with respect to r are cancelled. It is just partial g over partial y, which is the main task, and same is the case from here. Partial theta cancelled, although we don't have to cancel. Partial g over partial y, which is the main thing. So this is the essentially a chain rule. So now we again plug the values. Fy is equal to this partial g over partial r. For convenience I will just rewrite this one as a gr. Now let's plug the value of this partial r over partial y. We have already calculated that partial r over partial y is basically y over r, and then plus this partial g over partial theta is rewritten as g theta, and then the value of partial theta over partial y, partial theta over partial y is x over r square. So fy is equal to y over r, this gr plus x over r square g theta. So this is the required expression for fy. But essentially question asks that we are looking the fy in terms of r, theta and the partial derivatives of g. So this y and x should be removed. So let's go one step further. It will be fy. So on the place of this y I can just plug r sine theta divided by r gr, plus on the place of x we can plug r cos theta divided by r square. This is g theta. So fy will be equal to sine theta gr plus cos theta divided by r g theta. So essentially this is in terms of r, theta and the partial derivatives of g. Same thing we didn't apply in the derivative of fx. So if I want to write that in the terms of required expression, so this will be equal to, x will be equal to r cos theta, so r will be cancelled, it will be just cos of theta gr. Negative y will be equal to r sine theta, so r will be cancelled, it will be sine theta over r g theta. And this will be the derivative of f with respect to x in terms of r, theta and the partial derivative of g. That is the required form. Now we look for the derivatives, the second order derivatives. We are looking for fxx. So let's find f of x, which means this fxx is basically the derivative of fx with respect to x once more. And we have already calculated the expression for fx, so this will be partial x, and the expression for this fx was equal to, yes, that was cos theta gr negative sine theta over r into g theta, sine theta over r into g theta. Okay, let's calculate the derivative of this expression with respect to x. Again, we can notice that this whole expression is not directly depending upon x, although it's indirectly depending. So we have to apply the chain rule again. So by the similar chain rule, so I will be rewriting this expression. So I will be taking the derivative of this whole expression with respect to r. This will be cos theta gr negative sin theta over r g theta, and here this is partial r over partial x. You can notice this is the chain rule because partial r partial r cancelled. It is essentially the same, partial over partial x from here. But we don't stop here, we take the second option as well, the second, because the function is also depending upon theta. So here I will be taking the derivative of the expression with respect to theta as well. So that will be cos theta gr negative sin theta over r g theta, and then to make it compatible chain rule, I have to take the derivative of theta with respect to this x. It is again the same thing because this partial theta cancel. It is the same, partial over partial x. Now we calculate this derivative, but before that we simply apply the derivative on each individual expression. So this will be partial by partial r applied on cos of theta into gr negative partial by partial r, and this will be sine of theta 1 over r g theta plus partial by partial theta cos of theta gr negative partial by partial theta 1 over r, yes, 1 over r. Then we have sine theta g theta, but I am missing one thing. Let me put bracket over here. This expression, which is partial theta over partial x, this partial theta over partial x, we have already calculated that. So let's plug the value of partial theta over partial x. Partial theta over partial x is negative y square, negative y over r square. So the value of that expression will be negative y over r square. Similarly, we have also missed this expression over here, partial r over partial x with the first one. So the value of partial r over partial x is, this is x over r. Alright, okay, now we calculate the derivative of each expression. So let's start calculating the derivative of this expression. So this is the derivative of this expression with respect to r. You can notice that this cos theta is just a constant. So this will be taken outside the derivative, so it will be just cos of theta, and that partial by partial r will be applied to only this g of theta. So this is the derivative of g theta with respect to r. So simply this can be written as g r theta. I mean, firstly it was derivative with respect to r, and now it's with respect to theta. And then on the second expression, you can notice this is negative, and after negative, this sine of theta is just a constant with respect to r, because theta and r are independent variables. So that sine of theta is taken outside, and the derivative partial by partial r is applied to 1 over r g theta, because they both are function of r. Since g is depending upon r as well as on theta, so g theta is also depending upon r and theta, so we can differentiate with respect to r. And outside we have already x divided by r. Now I go into the second line. Again we apply similar arguments. So here we are taking the derivative of this cos of theta gr with respect to theta, but you can notice they both depend upon this theta, because cos theta is clearly depending upon theta, and gr is also the function of r and theta. So we apply the product rule over here. So let's apply the product rule. So it will be the derivative with respect to theta of cos of theta, that gr will be written as it is, plus that cos theta will be written as it is, and we have to multiply with the derivative with respect to theta of gr. After that we have negative, and you can notice again the derivative is with respect to theta, so this 1 over r is just a constant, so that is taken outside, negative 1 over r, and the derivative applies, this is the partial derivative with respect to theta, it applies on sine of theta, g theta, which will be simplify in the next step, and here we have negative y over r square. Now we further apply simplifications over here in the first one. So this is cos theta, gr theta, negative sine theta. After negative sine theta we have two functions, we have 1 over r and g theta, and they both are depending upon r, and we have to take the derivative with respect to product rule. So I will take the derivative, so I'm applying directly. So derivative of 1 over r will be basically negative 1 over r square, and g theta will be written as it is, plus this 1 over r will be as it is, and the derivative of theta with respect to r, it will be just gr theta, and outside we have x over r, and then plus, okay, now apply the derivatives over here. So derivative of this cos theta will be negative sine theta, gr is there, plus cos theta, and the derivative of r with respect to theta, it will be just gr theta. After that we have negative 1 over r, and here we again apply the product rule. So I'm going to apply the product rule directly. So derivative of sine theta will be cos theta, and g theta will be as it is, and then sine theta will be rewritten as it is, and the derivative of theta with respect to theta will be g theta theta. And here outside we have negative y over r square. And let's do further simplifications. Now I firstly simplify the bracket, and then we will multiply with x over r. So this will be equal to cos theta, gr theta, minus plus 1 over r square sine theta, g theta. I'm basically multiplying over here. Then minus plus minus, it will be 1 over r sine theta and gr theta. And here outside we have x over r, so x is basically r cos theta divided by r, and we can notice that this r is cancelled with the r, so ultimately we are only left with the cos theta, plus in the second bracket here we have negative sine theta gr plus cos of theta and gr theta. Okay, let's multiply negative 1 over r inside. So it will become negative 1 over r cos theta, g theta, and negative 1 over r sine theta, g theta theta. And here we have this expression negative y over r square. So negative y is basically r sine theta, and here we have r square. So this negative r cancelled, this 1 r is cancelled, we are left with sine theta over r. So here we have cos theta. I am going to multiply everything. This cos theta will be multiplied with the very first expression, which will become cos square of theta gr theta plus 1 over r square sine theta cos theta g theta, and negative 1 over r sine theta cos theta gr theta. And this was simplified the first line. Now we simplify over here. This is negative sine theta over r, so when it's multiplied with this one, this will become negative positive. So 1 over r will be there, sine square of theta, and this is gr. Then we have plus cos theta gr theta multiplied with the same expression. So again it will be negative 1 over r, and here we have cos theta, from here we have sin theta, so it will be sin theta cos theta, and it will be gr theta. And then this minus and minus, they will become positive, and here we have 1 over r, and there is already 1 over r, so it will become 1 over r square, and this will be sin theta cos theta g theta, because this is g theta cos theta from here and sin theta from here, so this will be sin theta cos theta and g theta. And ultimately we write the last expression. This is minus minus plus, this 1 over r and 1 over r from here, this will be 1 over r square. Yes, and then we have sin theta, and that sin theta, that becomes sin square theta, and then we have g theta theta. Sunny, I just noticed that I have made a mistake in the calculation, maybe in a few steps back. Let me just check that. I think over here. Yes, over here. So when I was applying the derivative with respect to r on this cos theta gr, I said that cos theta is a constant with respect to r, so that will come outside, and I have to take the derivative of this gr with respect to r, but I mistakenly wrote it as gr theta, but this is grr. But now I will quickly revising that if I have made any other mistake. This is negative sin theta outside, partial by partial r 1 over r g theta, which will apply the product rule, x over r on the place of that partial theta over partial x, no sorry, on the place of that partial r over partial x. And in the second expression, here we have to apply the product rule, negative this 1 over r is a constant with respect to theta, and the derivative with respect to theta will be applied on sin theta g theta. So I'm just quickly revising that if okay, so this will begin that same grr. So yes, this will be again, yes, so it should be same grr. I think everything else is okay. So when I multiply from outside, because I have cos theta, and this cos theta will be multiplied with cos, it will become cos square theta, and it is grr. Okay, now let me check if is everything okay.